Top of the middle of the day to you boys and girls. We're at the bench in the shop for another little narrative session, and today for your viewing pleasure we're going to be talking about the little bit that I know of octane boosters and mix oils. I've been fielding a lot of inquiries as to which mix oil I actually run. I'm going to talk about a lot of history, explain a little bit how I arrived at the choice I made. Then we're going to show how through the data in the spec sheets that it's pretty much spot on. And I basically landed on this particular mix oil about 17 years ago, and I started looking at the spec sheets about 2 years ago. So anyway, throwing out the disclaimers right off the bat, I am no expert in this field. The other part of it is I'm going to be butchering some words for you surely in this process, so please forgive me when I mispronounce things. So it'll be long and tedious as well. We're going to be looking at paperwork. I'm going to probably segue off here and there as things pop into my smaller than average sized brain. So let us begin. I guess if we talk about the history part of it for a second, if we look at petroleum, gasoline, if you look at that concept, it's a two-part word, two-syllable word. Petra is the Latin word for rock, essentially. So we have petro is a derivation of petra, meaning rock, in Latin. As far as I know, the oleum part is the Greek word for oil. Put those two together, you have petroleum. Just a little history, conceptual idea. We do have a base oil handbook. I'm digging in this thing every once in a while when I get something new in. I want to check something out that I don't understand. You can see it's pretty involved. What we're going to be looking at today is viscosity, flashpoint, and density. Those three things are pretty important to me. The other part of the equation is, are we talking about which group the oil that we like, which group it falls into. There are 5 basic oil groups. There are 4 basic crude oil classifications. We'll try to touch on a whole bunch of stuff. I guess if we go back for a second, I had 1,390 that I cut probably about 6.5, 7 million board feet with over quite a time frame, because I was running other saws in that period of time as well. It still had machine grooves across the sides of the piston, top to bottom. The thrust surfaces were shiny, of course, but we're talking, 1,500, 1,600 log truck loads of logs, basically. I don't even know. A lot of volume cut. So I've been running one particular oil for a long time. For the most part, I've kind of segued off and sampled other oils over the last few years. Never really strayed away from the original choice. I did do back-to-back testing in 5-gallon cans, like I said, about 17 years ago, when I kind of started on this fully synthetic kick. Tried 12 different versions. A lot of them are in this book. Some of them aren't at this point, but we'll be looking at some of that information. So back on the base oil handbook, we already discussed what we're looking at as far as, well, at least the 3 main criteria that I look at. And there's just some interesting things. They got mineral oil base. You have a naphthatic base oils. They have a paraffinic oil. There's talk that there's different applications. Some might work better in the application. We're talking about chainsaw engines. Chainsaw engines run hot, 350, 400, 450. A lot of the oils nowadays have a really low flash point, but I kind of digressed a little bit. I guess we should go in order as it appears in the book. It says right in here, naphthatic oils have some advantages over the paraffinic. Goes into solution a little bit better. Seems like it handles low temperatures a little bit better, and it seems like it also handles high temperatures a little bit better. You see this particular base oil in a lot of the high quality, fully synthetic race bike 2-cycle engine oils. Just as a side note for me looking at the spec sheets, If we get on the viscosity concept, essentially film strength is what viscosity is. It's the oil's resistance to flow, technically. So the higher the viscosity number, the more it resists flow. We can see that in the chart. The viscosity is very high at a low temperature. As the temperature gets higher, the viscosity drops. You can see there's a high VI number and there's a low VI number. So there's different viscosity numbers for different oils. If we extrapolate that concept into chainsaws operating hot as compared to a water-cooled engine, then you want your viscosity to be a high number. We'll get into that a little bit more as we go along. Flashpoint is another interesting concept. It's specified for safety reasons, of course. Really what we're interested in is it indicates how volatile the oil is. There's a couple methods that they use to establish that number. One of them's Penske-Martin closed cup method. They'll usually mention that in their spec sheets, maybe the Cleveland open cup. Let's just say that it takes less heat when the cup is closed for the oil to reach its flash point. So that's something that we need to think about when we're checking out the oil itself. The other part of it is the density. As compared to water, the numbers range from the lowest I've seen so far is 0.82, the highest is like 0.962, so we're getting close to the density of water. And some of them, density is good because you don't want the molecule to be low density and have it be deformed easily. So the higher the density number, the more dense it is, obviously, but the more it resists being crushed. If you think about the concept of heat and pressure in a motorcycle engine, the piston's going around at a very high rate of speed compared to an automobile engine. You want the molecule to be tough, essentially. If you think about in concept, from what I understand, talking to the tech people, petroleum-based oil, the molecules form strings that are in line with the stroke. There'll be strings and then there'll be empty spots on the cylinder, like an empty row and then a string and then an empty row. The difference between the petroleum and the synthetic basically is the synthetic coats fully around the bore, where the petroleum is kind of forming strings and then open cylinder wall and then strings. That's according to the tech people I've talked to. I thought that was an interesting concept. If we get in here a little bit further, we're going to just touch on a few things. 4 types of crude oil, very light oils. That would include the jet fuel, gasoline, kerosene, middle oils or middle distillates, diesel fuel oils, some domestic fuels like crude. So they basically have it categorized, and then heavy fuels, and in those they talk about the West Texas Intermediate. That's a high quality sweet Brent blend that comes out of the, I think that comes out of the ocean, North Sea, yeah. And then there's the OPEC basket. That's kind of a blend of a bunch of oils from the Middle East. Where's this last one? Well, those are the 4, I guess, if you look at it like that. Anyway, we're rolling right on through. If we look at the oils that we're interested in, there's 5 basic groups. Group 1 is the least processed or the least refined, and they use solvent refining. We kind of have to look in the back here for a second. We can look at hydrocracking. That's one method that you take crude and end up with a lot of the components, the jet fuel, the diesel, the mild oil, the gasoline. It's like a process of cracking, hydrocracking they call it. We got a picture of the process. It's pretty involved. That's why refineries are so big. They're doing large volumes, but they have to do a lot of processing to the crude oil. Another part of the equation is the solvent extraction, or it's called liquid-to-liquid extraction. That's another way to separate the crude. If we look further back, if you're looking at motorcycle mix oils, they talk about 3 different types: semi-synthetic, a mineral base, or a fully synthetic. And then kind of lastly, in this part of the equation, we're looking at some of the additive ingredients. There's packages, they call them, detergents, anti-wear agents, all kinds of stuff, biodegradability components and antioxidants, and so that takes up part of the blend as well. Sometimes you have to read in the spec sheet, but if we get back on the oil types for a second and look at, we're concerned with group 4 and group 5. Group 4 is the most regulated of all of them, from what I understand. Polyalpha olefins, they're pretty stable at extreme temperatures, which you want, obviously. We talked about that. They do very well in hot weather. Group 5 has kind of a collection of whatever's not defined before that. Some of your naphthatic oils are in there, along with your esters. For your fully synthetic oils, we can look at synthetic oils and the concept of their esters are derived from carboxylic acid, so you're dealing with a negatively charged component. Maxima talks about being highly polarized esters. I don't think that was something that they set out to gain. I think that's part of the process, and it ends up with the materials, compounds they're working with. But polarized molecules, they'll basically seek out your hot spots in your cylinder, which is pretty sweet. So that's one of the things. I don't know if it's a byproduct. I think it, from understanding, if I'm understanding the tech people right, it's like a byproduct in a way. It's not really what they tried to get. So we kind of covered a lot of ground in here. We should probably segue over into the rest of it, since that's the bulk of the concept here. This information I've been collecting for a little while. You can see it's impressive. We talk about octane rating, and that is the concept of the octane number you see like on the pump, for example. It's the octane is an additive to the gasoline. It helps stabilize it. The higher the octane number, the more it will resist detonation, the higher the temperature goes up. So that's kind of the concept. Interesting. Segue off, we can see that there's a RON, which is a research octane number, and a motor octane number. There's different criteria for those. You see it at the pump. R plus M divided by 2 gives you your end octane number at the pump. So it's kind of a, I don't know, interesting concept. We can look at different places around the world. They talk about what they have rating-wise. We're not going to dwell on that too much. We will check out auto ignition temperature. You get your pre-ignition in concept auto. Ethanol is actually quite high compared to straight gasoline. That's why there's the concept of octane, I guess. We're trying to stabilize the gas. It's important to note that the lower the octane number, the faster it burns. The problem is it burns in pockety. It kind of burns in little pockets. The higher the octane, the more controlled the burn is. The more the burn acts like if you were to drop a pebble in a lake. When it's calm, everything radiates out from the center evenly. The higher the octane, the better that situation is happening. So if you think about engines, we bump the compression in a chainsaw, we run them at a really high RPM, and so you want fuel that's relatively stable to a point. I've tried to run about 98 to 100 octane for a long time. Tried race gas, blending race gas, pump gas laced with boost. For the last few years I've been doing that for the most part. Ethanol doesn't give you quite as much bang for the buck, but it burns a lot cooler. There's some evidence in some applications where you get actually a bit more efficiency. Depends on how it's introduced into the process, but we could go on and on and on about that. We're not really so much interested in that. It's important to note that if you have a concentration of 2%, let's say, which equals 50 to 1, and you add any kind of octane boost numbers to that, you're actually changing your final concentration. And so we need to kind of think about that as a process. My friend, he's about 70. He was the tuner for Jimmy Felice, and I think it was 1977 when Jimmy won the Daytona 200 on a 2-cycle 250 bike. We've had lots of conversations over the years. The guy's built, he built a Harley that won the San Jose Mile, beat the factory Harley bike, so the guy knows what he's talking about. 2% concentration is what he did for years and years. I've always ran a 2% concentration. That equals 50 to 1. I've tried down to 40 all the way to 60. You might get a little more low end down with a little bit more oil. Residual oil, and you definitely get an engine that winds up a little bit higher, but they seem like they don't have as much power when you get up around 60. I ran 50 to 1 for years and have multiple saws that have cut millions and millions of board feet, so I don't find a longevity issue. Got to check the time, make sure we're not getting too far off. So as far as octane boost goes, I've ran this for years and years. Generally, when they talk about there's a maximum you get out of it, 1 ounce per gallon seems to be kind of a normal number. I tried all of these recently. This is probably toxic waste in a bottle, but it's super bad. It says up to 6 full octane numbers, but again, that's at 1 ounce per gallon. I have a tendency to run 1.25 ounces to 1.5 ounces, depending. This 1 ounce does 3 to 4 numbers, so if you were working with 91 octane, you add 1 ounce per gallon, you end up at about 95 octane. I was running 1.25 ounces, 1.5 ounces pretty regularly, trying to get that 98 number. I like this particular version. There's nothing in it that's too bad, no phosphorus, a few other things that it doesn't have, but it's got a dye in it. Changes the color of my exhaust, and so kind of iffy on that one. If you're running it in a kind of a bike or a snowmobile, this would probably be my choice. Just as a side note, if we get a little bit further into this process and start looking at the mix oils themselves, we see that it's all arranged alphabetically, and so if we consider AMSoil as it starts with an A, we look at that for a minute. We can talk about a lot of the methods of viscosity. There's the Saybolt seconds method, and you don't see that so much. You see the kinematic. Pretty much everybody uses the kinematic criteria when they're listing the viscosity. A lot of them only list the viscosity at 40 degrees Celsius. Had to make a few phone calls. I like to look at the 100 degrees Celsius number, which is 212 Fahrenheit. We see that it's relatively low in the Sabre. We see that the Flashpoint's not that great as well, really low. We look at Dominator because they're pretty much relative density is 0.87, pretty much on the low side. Just as an example, if we get over a little bit further, I had a guy, what do we got? Okay, so here we go. Kinematic viscosity, again, is pretty low. You did talk about the Cleveland Open Cup method, how they got to the Flashpoint. So we're just kind of looking for those numbers. Relative density again. I had a guy from Arkansas give me a shout out, I guess, so to speak. I hadn't really been around Bell Ray since my racing days back in the 80s, but he was talking about HR1, so I bought some, ran quite a bit of it, I guess. You can see here we got a Solvent Naphtha again, kind of interesting concept. If we look at this particular oil, for example, we see that the kinematic viscosity isn't that great at 100 degrees Celsius. It's got a killer density though, and if we look at the Flashpoint, it's like closed cup method and it's not even 400. So there's things that a person's looking for when you're checking out the particular oil. Some guys run it because their dad ran it. I was exposed to this one. A saw came in. It was pretty dirty inside for the amount of time it had been run. So I was kind of curious. A lot of times what you look at is, you can see this is a mineral oil. We talked about that base oil concept a while back. It gives you kind of the concentrations. And then we got the trade secret part. A lot of times the burn is the clean or dirtiness of the burns established by the additive package, if you will. We have some Dolmar oil. I checked out the Honda HP2. I've actually run that. That was in that early testing from years ago. If you look at what we have going on with it, synthetic lubricant, lubricating base stock, you can see the numbers. This stuff burns pretty clean. Really low Flashpoint though, but it has a really nice viscosity at 100 degrees Celsius, and it's got a nice density. So there's a lot of choices. This particular mix oil right here I won't run. Here is why. We can see 288 that's on the bench right now. You can see what you get when you're running that particular mix oil. A lot of issues, a lot of buildup. They act funny. You can see it's just gross. It's like goo. It's like a goo. They won't hardly crank over when you take the spark plug out. 390 is an example. This has been run for an hour or so, a couple hours at the most. So that's kind of the reason why. We can look at some Still Ultra, couple hours, but running super rich, not doing too bad. If you want to talk about the Still mix oil for a second, we'll take a look in the back because, like I said, it's alphabetized. Omni Specialty Packaging out of Shreveport, Louisiana is making this oil for Still under their criteria. One of the things about it, we look at the kinematic viscosity is really low, so the film strength isn't great. The density is good. The Flashpoint's pretty good, 428. If you look at, we have a complex ester, but there's also some cleaners in this, petroleum distillates, kind of a solvent type oil. If you quit running that particular version and started running this, you're going to clean it up a little bit. Then you can transition into something that's a total or complete ester. I've heard some talk about this particular oil. I ran it myself. It has problems with power valves, clogging them up. Tried the Torco. Lubricating Specialties is who's making that for these people, but relatively low numbers. Tried Silcoline. I haven't tried the Schaefer's to this point. Tried the Opti 2, and what I landed on was the Motul. If I was running a water-cooled machine, this would be my choice. It's a triple ester. That'd be it's got a little bit lower Flashpoint. The other two numbers are pretty good. The Motul, we have the road race version if you're running super hot saws. If you're running like kind of medium to super hot saws, you're running the off-highway version. But they have three of the three criteria I'm looking for. They're the highest average of any oil I've found so far. So I landed on that oil 17 years ago, ran the crap out of it, cut a lot of volume with a lot of saws, never having any problems. That's my particular choice. The data backs it up, and I thought that was interesting when I started doing a comparison. So anyway, we covered a lot of ground. Hopefully you found this interesting and enjoyable. Let us be thankful this holiday season and be thankful for our families, and have a blessed day, whatever you might be doing on God's green